Hello students. So today we are going to do in linear programming problem, which is chapter 12. So before that, we need to know what is objective function, what are constraints, how do we formulate a linear programming problem, what is optimization, what is feasible solution, and what is optimal solution. So what is your objective function? Objective function, whenever you are given a problem, suppose a company is producing products. So what it wants to maximize its profit by selling the products, and it wants to minimize the cost. Minimize the cost means the raw material which it will be buying, it wants to reduce the price of that. So in these kind of situation, if we formulate these maximizing profit or minimizing cost, these ideas into an equation, that is called the objective function. Constraint. Now what are constraint? Constraint are limitations. Now if I am producing some products, what are the constraint? I have limited number of hours my machine works. I have a limited amount of money. I have limited amount of time. So these are constraints. So in the problem, when you read, you will see there is limitations for machine, for money, for production. So those are constraints. Now when you formulate your objective function and constraints according to the given problem, that is called formulation of linear programming problem. Until and unless you formulate your linear programming problem, you will not be able to solve the problem. Now optimization means we are finding the maximum or minimum value, the point which gives the maximum value if you want maximum, the point which gives the minimum value if you are minimizing your objective function. So now what is feasible solution? Now when we will be solving using graphical method, we'll be having shaded regions. So the shaded region, all the points in the shaded region are called feasible solutions. Those are also called feasible points. Now from those points, one value will be giving, one or two will be giving you the maximum value or the minimum value. So those, if you are asking for, if the question is asking for maximum value, then will be your optimal solution. That point which gives the maximum value, that will be your optimal solution. If the question is asking minimize, so the point in the feasible region which gives the minimum value is called the optimal solution. Now there are two methods of solving linear programming which we will be doing here. That is graphical method. Under graphical method, we will be having case 1, which is bounded region. Another case will be unbounded region. Okay, now before moving to solving linear programming problem, I want to give you one concept which we did in class 11. So that is intercept form. It is a easier way and faster way of finding the points for the given line. Intercept points for the given line. So suppose we have a line which cuts the x-axis and y-axis at these points, and we can use slope formula. So using 2-point slope form, we can get this equation using these 2 points, and then if we divide both sides by AB, then we will be getting this equation. So this equation will be very helpful in solving linear programming problem. And now we'll be doing a problem from exercise 12.1, question number 8. There are many concepts which are covered in this problem, so that's why I'm doing this. After this, you will be able to do many easier problems. Okay, the question says maximize or minimize. So you have to find both the points where we have maximum or minimum. So the objective function is z. So this subject to these constraint, x plus 2y is greater than equals to 100, 2x minus y is less than equals to 0. So this was given in the question. In solution also I have written it once again. Now what about this two? These two are telling you that the graph which you'll be drawing, it will be in the first quadrant. Now if I say x greater than 0, x greater than 0 means what? X equals to 1 2 3 4, so this side. Okay, so x value should be on this side according to this point. Okay, x greater than equals to 0, so it can be 0 or on this side. Now y is greater than equals to 0, that means on this side. So our graph will be made on the first quadrant. Okay, now let's go back. Now I have given the points, name 1 or L1, line 1, second one 2 or L2, third one 3 or L3, and this one, this was just given to tell you that your graph will be made on the first quadrant. Okay, now so this is our inequality, but for solving purpose we'll be using equal sign. Okay, now so for L1, x plus 2y equals to 100. So using intercept form, you can see that I got the point 100 comma 0 and 0 comma 50. The second one, you can see there is a 0 here, but our intercept form was x by a plus y by b equals to 1. Now if there is a 0, you will not be able to bring 1 until unless you add 1 on both sides. So I will not be doing that. Instead I will just solve this x with x and y. So if x is 50, you can see y will be 100. X is 0, y is 0. This you have all know. Okay, now for line 3, you can see if I divide by 200 both sides, the points will be 100 comma 0 and 0 comma 200. That will be my point. Now I'll be drawing the graph for these 3 points. Okay, so I'll be drawing the graph. I have already drawn the graph, so I will show you now. So you can see the points I have plotted. The points I have plotted. The first point is, you can see the first point 100 comma 0, which is 100 comma 0, which is here, 100 comma 0 and 0 comma 50. It's here. I have plotted and drawn, and I have written line 1. Now let's go to the next point. Next point is 50 comma 100. 50 comma 100 will be here. See the 50 comma 100, this is 50, this is 100, so this is 50 comma 100, and 0 comma 0 is here, so I have drawn a line. Okay, let's go to the third point, which is 100 comma 0. 100 comma 0 is here, and 0 comma 200 is here. And whenever you are drawing a graph, don't forget to give scaling. So on x-axis I have given that these, on x-axis I have given that these small 10 small divisions, this 10 small divisions is equals to 20 units. You can see this 20 units. Okay, this is 20 units, and on y-axis you can see 10 small divisions. 10 small division is how much? 20. So this is very important, you should write this. Okay, now after this we will move on to this. Okay, now we need to check which is our solution region for each line. Okay, so for line 1, you can see line 1 is passing from where? This is our line 1. This is our line 1. So you choose any one point on any side of this line, but not, it should not be on the line. No point on the line. Okay, so I have taken 0 comma 0 for line 1 at 0 comma 0. So I have substituted. I see that 0 is greater than 100 I am getting, which is not true. So if it is not true, you will move away from the point. If it is true, you go towards the point. So if, see, this is false, so I will be moving away from the point. You can see the brinjal color, it's moving away from 0. So for this line 1, see. Okay, for line 2, why I didn't take 0 0? Because I see that the line is passing through 0 0, so I took 20 comma 10, this point 20 comma 10, which is clearly on this side. So I see again, after putting the values, I get 40 minus 30, which is 40 minus 10, sorry, this is 40 minus 10, the answer is 30. So is less than 0, it's false, so it will not come towards the point, it will go away from the point. You can see the green color, it's going away from the point. Last L3, so you can put L3 in L3. I can see this is my line 3 and 0, 0 is not on the line, so I can substitute here. I see 0 is less than equals to 20, which is true. 0 is less than 20, so I will come towards the point. So you can see, you have to find the area where all the three colors are lying. Here you see only green is lying, here you see only two colors are lying, here you see only one color are lying, but here you see all the three colors are lying. So this will be my feasible region. This you can shade it with pencil. This will be my feasible region. Now what should I do? I will mark the region which is bounded with some name. So you can see I have given A, I have written the points. B, I don't know this point. I can use the graph to find, or I can solve the two equations L1 and L2, because they are intersecting here, and this point is found by this intersection of these two lines. So I can solve these two lines and then get the point. Or if you can find from the graph, easy point, like see this is lying here 20 and then 40, so directly you can find or you can solve. Okay, similarly the C we already have, so this one D is 0, 200. So these are the 4 points which I have. Now for this point B, I'm showing you how to solve. You can use your class 10 substitution method, cross multiplication, no need for cross multiplication, simultaneous method also you can use, simultaneous equation method that you can use. So you can see for B we solve L1 and L2. So I have solved, I got, so the point B is this, so I have written it here. Okay, now I solve for no need to solve for C. So now once you are done with this is your shaded region. You got this point. We solved this because we did not know about the point. Okay, so do not write this one because already we have this point. So now we go to find the optimal solution. Now from the graph you write all the points, you write make a table like this, corner points and your objective function. So now you can see the points here, A, B, C, D. So I have written it here, and this is the value of X, this is the value of Y. So X, Y I'll be substituting in my objective function and then I'll be getting values. Okay, so you can see there are two minimum values, same values, so 2 points will be giving us minimum values. Now it will depend on the question which one we have to select, but for now it has just asked minimum, so we'll be taking both of them. And then maximum is at this, so Z is minimum at this point and this point, and maximum at this point. So this was the bounded problem. So I have shown you the method also. Don't forget the points in between which we have done. Now let's go to unbounded. Now this is question number 9, which is for unbounded problem. Okay, now they are saying maximize Z equals, so this is our objective function, this is our constraints, and there is Y greater than 0 but X is greater than 3. So this will also represent a line. We know Y greater than 0 what it is. Okay, now for line 1 directly I can say X is equals to 3, which is a straight line parallel to Y axis. Now for line 2 will be having X plus Y equals to 5, and using intercept form I'll be having the points like this. Now for line 3 you can see that X plus 2Y equals to 6, and then I use the intercept form, same thing, we will be getting the points. Now you see I'll be drawing the graph for this. It looks a little messy, but when you draw Take two big blocks as one. I have taken one, that's why it has become clumsy. So for two boxes you take as one. It's not a big, you don't have big numbers, so it should be easy to plot those points. So x equals to 3 is a straight line. You can see this is a straight line, x equals to 3. For second line I have written line 1 here. For second, and see the points are 5, 0 and 0, 5. I have joined this, so this is my line 2. And then line 3 you can see 6, 0 here, and then 0, 3. This is the line. Now I have drawn an extra. Okay, this is the line, this is the line 3, this one. Okay, so there you can see two extra lines here. Okay, so this line is not important, you can neglect this line. Okay, you should neglect this line, and this line you neglect, this one you neglect, and then this will be your line which you will be using, so neglect this line. Okay, now what we will do, we'll find the region, common region. So now see, for line 1 at 0, 0, 0 greater than equals to 3, which is false, so I'll be moving away from 0, so this is this side. For line 2, you see, for line 2 you know the equation. Line 2 equation is x plus y greater than 5, so 0 plus 0, so 0 is not greater than equals to 5, so that is false. So again for line 2 I'll be going away from the origin. Okay, line 3 also same thing, I'll be going away from the origin. Now you can see the common region is this one, green, then you can see this brown color, and then you can see the brinjal color. They are all meeting here, this one, all are common here, so this is the region, feasible region. Now you can see this feasible region is open. How will you decide till where will you get the maximum value? You may get maximum value anywhere, so which one should be our maximum value? Okay, the question says maximize. Now what we will do, first find the corner points. So I already have the corner points. Okay, so see, the points are B, C and D I have given. So B I need to find, C I need to find, and then D I already have. So for C we solve L1 and L3. L1, L3 I have seen, elimination method you can use, and then y is equals to 1, x is equals to 4, so the point is this. Okay, so and for B you can see, for B we solve L1 and L2. So x is equals to 3, x plus y equals to 5, so I got the point as 3, 2. So 3, 2 point is this one, and 4, 1 is this one. Now I find the corner points. So same like that previous problem, corner points, z is equals to this given, and then these are the points which I get. But you may or may not, but one, this one maximum, can you see? So one may or may not be the maximum value, because the region is unbounded. We will draw the line for the equation this. Now from where did I get this equation? Did you see your objective function? Yes, so from the objective function, whether it is maximize or minimize, if maximize you put greater than 0, maximum means 1 or greater than 1, we have to go greater than 1 for maximum. Minimize means minimum than this, so we will put a less than, we will put a less than sign. So here maximize they are saying, so we will use greater than 1. Now you plot the graph for this on your graph. Now I have done that, finding the points. I found out the points. You can see this. So the region also, shaded region also I'm finding the solution region. So now it is false. So my graph looks like, my line looks like this one. This is my line. This is my line. So if you solve on graph, you will know this will be my line. Now the solution region for this line is coming, because 0 comma 0 greater than 1, which is false. So I'll be going away from 0. That means this. So now you can see, if any of these 3 points lie in the solution region of this line, then there will be no solution. If this shaded region of this line is free from all the points, that means these 3 points, then you can use the answer which you have got already. But here you will see that B is inside the shaded region of this line, the line which you have drawn just now. B is inside the shaded region of this line, so we will not have a solution, will not have any solution. So since the feasible points are common to this feasible region, Z has no maximum value. So these are the 2 types of graphical problems in linear programming problem. I hope you understood. This is Suraj sir. Thank you.